Hello, Thomas. Nice to see you.
Good to see you.
So Thomas is going to be talking about, I think, a new topic for this, at least for our audience, which is lift printing for high viscous materials in combination with laser drying. So looking forward.
So I'm speaking about today on lift printing for high viscous materials in combination with laser drying. A short introduction of Coatema and myself. My name is Thomas Kolbusch. I'm Vice President of Coatema Coating Machinery. I think a lot of the people in the audience will know me. Coatema Coating Machinery is focused on coating, printing, and laminating equipment. We are focused on tech markets, and we are specialists from the company vision from lab to fab. We have a big R&D center in Germany with 8 pilot lines, and all the technologies I'm showing today are also available for testing in the R&D center. We not only building equipment, we have a big service part with the R&D center. We're doing public funded projects. We have a huge R&D network. We have cooperation partners, and we understand our customers' markets. Basically, what we're doing at the moment, we enable net zero. We are very strong in green hydrogen, coating system, fuel cells, batteries, and third generation solar. And we normally use coating systems to apply a functionality to a substrate. So we are coating ink onto the substrate, we are drying the ink, and this gives a roll-to-roll system a functionality. And most of the systems we are using today are systems which are analog, so they're not digital. They are proven production systems, but nowadays we think we have to go into more digital operation. If you go digital, you have the same number of coating or printing parameters you face with the analog systems. So that's one part of our R&D team to find out rheology, viscosity parameters for the different application systems and for the different drying processes. So there is a bunch of different application systems available in coating technologies and also in printing. Basically, the main feature here is it's depending on viscosity, on rheology behavior, which systems you can use in your operation. And then, of course, if it's, for example, intermittent coating in batteries, then you're also limited in the application systems. So the standard system we also use in printed electronics a lot nowadays for perovskite solar cells. For other applications is slot die coating. That's a proven system for doing very thin layers, very accurate operation, 1% accuracy. Coatema is doing their own slot dies. So basically we do a simulation of slot die tools with COMSOL, and then we are building these slot dies up to 2 meters for different applications. The slot die is a non-contact method. We're controlling a meniscus in the operation, and this meniscus can be very well analyzed by the pressure relation inside of the manifold. It's a very well-known operation. Slot dies are existing since 50 years, and everyone is looking for the stable operation window, depending on the speed, the gap you're operating the slot die, so it's a non-contact system. And of course, also the capillary number means the distance of the slot die lip to each other. So with all these numbers, you can use a lot of mathematical formulas, and you can be very precise in your dry thickness calculation before doing the operation. With the slot die, of course, you also can do structures like squares or rectangles and other applications. But for example, you cannot do a round shape. So with the round shape, you have to go into printing methods. And using their standard printing methods are not suitable, for example, for thicker silver ink applications, or in this case here for batteries. So we looked into higher viscous systems we can use for operation, because here you see a fuel cell coating trial with one of our slot die systems where we have IP on. This is working with a piezo, so very fast closing and opening of the slot die lip, but it's still analog. It's not flexible. If you change the design, you have to change the mask inside the slot die. So here we're looking since the last 5 years into digital fabrication.